Michael. How's it going?
Hi, guys.
Hey, how's it going?
Hi, how's it going?
So Benji, that looks very prepared.
I've been doing a lot of streaming recently to small audiences. But yeah, I thought I'd load it up, get it ready. Then also when I'm like miles behind with the chat, with the with taking notes, people will spot that, maybe help out.
Okay. Get this out. Okay. Are you using OBM or
OBS, yeah.
OBS? Yes.
I knew what you meant.
Hello, everyone.
Hello, how's it going, Hugh?
Good. How are you doing, Benji?
Yeah, pretty good. Pretty
Awesome.
good.
Awesome. Thursday has been going well.
It's been busy. It's been a long one.
Yeah. Yeah. You're a few hours ahead of me. So how is the future?
Yeah, not too bad. Lots of cool
Good.
folks hanging out on a Zoom chat.
Yeah, good.
You got that to look forward to.
Yeah, sounds good. Sounds good. I like it.
Good to see you, Ivan.
Yeah, very good.
Hello. Good evening and morning.
Hi.
Hello, hello.
Hi.
Hello.
Hello. Hello.
Hello.
Hey,
Hi,
friends.
everyone.
Sorry
Hi.
for joining a little bit late. Let me just make sure we don't have any lagging pull requests. Oh, I see one. If your name's not on the agenda yet, please just go ahead and send a pull request. I'll keep refreshing that in case I spot any more. Let me pull up my agenda file and then we will get started.
I see.
All
Ivan
right.
is joining.
Yeah, I just merged Yvonne's. I don't see him here yet, but I suspect. Oh yeah, I do see him. There you are. A lot of squares on the screen today. Easy to lose track of folks. 17 folks here. Fantastic. All right, everybody, let's kick things off. So welcome to the May 2022 GraphQL Working Group. As we all join here, that means we agree to the membership agreement, participation, contribution guidelines, and code of conduct. As per usual, those are all linked from the agenda file in case you ever want to go reread through those. I wrote some of them. I think they're pretty good. You should take a read sometime. As we always do, let's do a quick names to faces. I think almost everybody here is a familiar face, but there may be a couple of folks who are new. Either way, always good to get quick name to face and make sure we have the right attendance. We will go in the order that it appears in the agenda file, which means if your name isn't there, please send a pull request to add it. My name is at the top, so I'll start. Hello, everybody. My name is Lee. And I don't see a drone here, so let's get past it.
Yeah, I'm Michael Stepp.
And I don't see a Brown here either. Or Joey. Hopefully some of these folks will show up later. Which means next on our list is Yakov.
Hello, hi, Yakov over here.
Hi, this is Roman here.
Hey everyone, Rob.
Hey, this is Tim.
Hey, I'm Alex, Matt Yelp.
Hey, I'm Benji.
Hi all, Hugh here.
I am Lauren.
Hi, I'm Matt. Hi, I'm Sahaj. Hi, Morris.
Hi, Anthony. Nice to meet you all. Or see you again.
I don't know if I see Arda here.
I don't think so. Hey, I'm Mark.
Hi, I'm Myron.
Hi, I'm Steven.
Any other names that we missed? Anyone here who hasn't got the name up on the board yet who wants to intro?
Yeah, I just did a pull request on mine, Lee. Hi, everybody. My name is Doc.
Welcome, Doc. Thank you for doing that. I will get those two merged. Thank you both. Awesome. Welcome, everybody. Great showing. Let's make sure we have good note takers. Benji, you've got a crazy background, which shows us all your notes. That's very cool. Benji, of course, always our note-taking champion, but Benji tends to participate in discussion as well. So if we couldn't get a handful of extra folks to volunteer to help take notes, that would be fantastic. I see some hands floating around in the screen. Thank you for that. Those notes end up being incredibly helpful. Let's take a quick look through our agenda, make sure we know what we're doing. We're going to talk about the intersection type proposal, an update on defer and stream, and some subtopics to dig into there. Looking forward to that. CCN status update and a rollout plan, and coming back to the one-up proposal. All right, fantastic. Before we do that, let's take a look at action items, if in fact we have any. It does look like, in fact, we have a few. We have 3. Let's go through them in reverse order. So we talk about the most recent ones first. Unions implementing interfaces. This was, I think, last meeting, next actions. And this one is set up for ready for review. Yakov, any extra color here?
Basically, we're going to be reviewing a little bit of that, I guess, with the discussion of the intersection type, as that's sort of the continuation.
Very cool. Okay. Thanks for making progress there. Closed. Implementing the one-off input objects in GraphQL JS.
So
that one's been floating for quite some time.
It has indeed. The pull request for that is up thanks to Eric Kessler. I have reviewed it and I'm happy with it. It needs review with people more familiar with the GraphQL JS, but I think it, as we will hear later, is ready to push it on a stage potentially. But we'll discuss that later.
That's awesome. Okay, fantastic work closing that. And the last part is defining processes for reporting and dealing with security vulnerabilities. Benji, you flagged this a couple of months ago, and looks like you have something up. Oh, we merged a security policy. Does that mean that this is just basically wrapped up?
I think so, potentially. So we have a security policy in place. I think we should probably add one to the .github repo that we have under the GraphQL organization. And that way it would be present on all of our different foundation projects. I was looking for some feedback from the TSC on that. Just a quick, yes, that sounds like a good idea. Would be sufficient.
It does sound like a good idea. Do you know if there must be some like GitHub tooling integrated in the same way that README files and code of conduct files and stuff
exactly that
propagated into the right places?
We just add a security.md file to that .github repository, and it then will just effectively appear everywhere. It won't actually be there as a file. It'll be there as however GitHub integrates the security announcement, but it will at least be present in some form.
That certainly sounds like a good thing to do. Hopefully that's a pretty easy follow-up task for us. Sounds like a good action item.
Sounds good. Let's take that as an action.
But this one is certainly wrapped up.
Yeah. Separately, can we add an action? There was the deprecation of input values that I think Ivan raised. And I think it's ready to be merged. It just needed that final editorial review. So do you mind if I file an action item for you there, Lee, to have a look at that?
Please do. Yeah,
cool.
I'm aware that's on my list, but always good to have a task to hold me accountable. All right. I don't see any other ones that need our direct attention. Thank you, Benji, for helping keep us honest and on top of those. Hugely valuable. We're not quite shy of closing any of our past actions. Oh no, that's not the case. There is in fact the one action from last meeting, which we did. That one gets to be closed. Very good, very good. Okay, I think that's all in terms of reviewing our action items. Oh, I forgot to ask. That's the set of things. We have these 4 topics up now. Is there anything else that we want to make sure we have on the agenda beyond these 4 topics? Sounds is fine. That means that we have an accurate agenda. That's good. All right, Yakov, I will hand it to you to tell us what's new with intersection types.
Okay. Can everyone see where I am? Sorry, my screen. I'm trying to
Yes.
share. Great. So this is from the GraphQL working group discussions. We started a new discussion discussing the intersection. Thanks to everyone for their feedback. I just wanted to go back to the motivating case. And I also want to reiterate that I came to this motivation not from really personal experience, but just from perusing some of the open issues. So I can't really say how urgent this is, if at all. But here's basically the motivating example as I best saw it. Let's say we have some generic interfaces. We're using, from what I understand, is generic kind of relay interfaces here, node, connection, edge. And let's say we have a type called a pet. Here we have it as an interface, okay? And then we have two types that implement that interface pet, and they also happen to interface node. I see over here that you could also say that pet also implements node. And the question is, how can we construct an edge? I mean, how can we construct a type that satisfies, that will implement edge, where edge has a type that, a field, sorry, that implements node. So we have basically two types, cat and dog, which are both house pets. And we want to say that these house pets are nodes. So how can we define house pet node to allow this? And I put over here, blank house pet node. And the simplest example is probably to make a union, maybe, of house. Well, there are a couple simple examples, but one option, going down to our options over here, is just to use regular unions. So if we define a house pet node as a union of house pet node, dog or cat, since dog and cat both implement node, we could have the types implement simply deduce, right? That house pet edge node type does implement edge. Because remember, what goes in here has to implement node. But if house pet node is only defined as the possible types dog and cat, well, that satisfies that, and that should be enough. Currently, GraphQL JS or GraphQL, the spec, doesn't allow you to do that because there's no knowledge. If you would put a union, there's no knowledge that that is defined to say that union specifically implements nodes. Even though it does in this case, it's not recognized. So we could change that, and we could say that because house pet node only includes types that implement node, then it does satisfy that interface. So the pro here is that it's simple, relatively simple, if we can get through the example. But the con is, or the con that was raised before I got to this issue, is that if for some reason we introduce another type of house pet, like that for some reason doesn't implement node, maybe it can't, maybe it doesn't have a concept of an ID, this would somewhat surprisingly break house pet edge, meaning it wouldn't simply be that type could no longer be, house pet edge couldn't represent the new type, let's say a fish type that for some reason doesn't implement node, but it would actually break the type system. Because if we tried to introduce fish, nothing, we would get a validation error that, well, actually, that we wouldn't quite get a validation error. Well, actually, we would. That house pet node would no longer, this type would no longer, all the types would no longer implement node, and so therefore house pet edge would no longer implement edge, and so we would get a validation error. So the suggestion was made to previously, again, before I came to this, was to add a constraint. And this was the language of the constraint. And we could change that keyword, but basically the keyword that, and this is what we discussed at the last meeting, we could add the constraint that that house pet node specifically implements. Here I wrote pet and node, but the key at this point is that it's implementing node. And at that point, the pro is that you cannot introduce a type to house pet node that doesn't implement node. The con might be that implements keyword is a bit misleading. We talked about that last meeting, that the member types are the ones that implement the interface of node and not really the union itself, because it has no fields. And that could bother you more or less. But generally speaking, we could change that keyword. I mean, that's just a question of syntax. But basically, the idea is to add some sort of annotation to house pet node to show explicitly that it's constrained. And the pro, again, is that we're protecting against the con from before. Now you can no longer introduce a new type, let's say, again, fish, to house pet node, because you would immediately break that constraint that has been added. So that's the plus. And we talked about last week, we talked about maybe trying to find examples from other type systems where this, a similar constraint was found. So, with my limited experience and knowledge, I basically came upon the use of intersections based on my, again, limited background, which is itself limited within TypeScript. So we could introduce two types. Basically, we could introduce over here, a regular union of house pet that are dogs and cats. And then we could have an intersection between those house pets and the nodes, and the type node. And basically our new type of house pet node would only be the set of types that satisfy all of these constraints that are house pets, pets, and nodes. And I put over here end pet just because we have that idea by interfaces that we should explicitly list out the parent interfaces. Anything that's a house pet would also be a pet. So and in fact, I mentioned above that anything that's a house pet could also be, anything that's a pet could also be a node. I mean, you could divide it over there. But basically, the idea is that we could use intersections instead of a separate keyword on the union type. We could use a separate type. So what would be the benefits of that? Again, you couldn't introduce a type to house pet node that doesn't implement node. It just wouldn't happen. It would be it wouldn't be within the set of types that fulfills all the constraints, and so it wouldn't be within the intersection. And if one actually tried by introducing it into house pet, that would be allowed, and we wouldn't have any problems there. You could have a house pet; it would go into like a fish, and it would go into that union, but it wouldn't end up going to house pet node, and nothing breaks. So the con of using intersections is basically, the pro is that we solved all of our other problems, but the con is that we basically have a new type and all the complexity that comes with it. I think I skipped over the con for having this additional constraint is if you tried to add fish to the union, you couldn't, right? Because there's that constraint. So if you needed to add fish, you might have to come up with another union that wasn't a node anyway. So you might, in this scenario, you might end up having one union of house pet nodes and one union of house pets. Whereas in this scenario of intersections, you have two different types, but they clearly define why they exist as two different types. Your house pet is a union, and then it's clear that the house pet node is the intersection of those unions. So you wouldn't have to like manually do housekeeping to keep those lists in sync. The house pet node would automatically be all house pets that also implement node. And finally, we could use a lot of interfaces. I think Michael, I touched on this last meeting, that now that we have, this whole issue was originally raised before we had interfaces implementing interfaces. But now that we do have that, we could introduce an interface that's the same as node, called house pet node. Meaning, so again, now we're thinking of not using a union either with a constraint or without a constraint, and not using an intersection, but going back to using our other abstract type interface. And that would be a house pet node that specifically says an interface node, and it's the exact same signature as node. And then we would just have to make sure to add the house pet node to the list of types that would have been in that union, so the dog and the cat. So the pro of this solution is that it's extremely simple. No additional syntax is required. The con is that we have a lot of, we may end up with a lot of types that are essentially duplicates of themselves, meaning a house pet node is the same thing as a node. So while it's true that a dog implements in this scenario node and house pet node, that's basically the same interface. And so our type system in this, which is our current, this is currently allowed, is not so expressive. On the other hand, the huge pro is that we have added no complexity. So thanks for listening to that summary, to all of you who have gotten through with me. I think those, I think Michael, I asked for sort of an RFC and a document, and I think this could be like the additional.
This is exactly what I meant. Because now we have the cases like, okay, these are the solutions to this problem, or these are possible solutions to this problem. These are the cons and the pros. That's what we had with input unions, and this helps to reflect on the problem and if this is really something we want to solve in one of the ways.
Yeah, and this could definitely be. I could, I think it might be a good idea then to shift it off into an actual RFC, and if people want to then have a more formal way of editing it, if they have other ideas and other pros and cons they want to add. I just, I'm basically done with my presentation. I think after going through all of this and thinking about all of this, I'm in favor of the intersection type. I think it, solves the problem, and it also points the way, having second order abstract types like this, solves a similar problem that we, I think it's linked somewhere. I'll try to post it in the chat later, of another issue with unions and subunions, and also, again, could types, really fulfill an interface, but our system doesn't represent that. I think it would be great to have, a robust type system that's, very strong. So I'm in favor of the intersection as the best solution to this problem, but I don't know that it's quote unquote worth it yet. I mean, again, these are the pros and the cons, but to actually put a pulse on how necessary this is, that I can't do for the group and would have to rely on others.
I would like to talk about if there's possibly another con here with the intersection type compared to the just having unions implementing interfaces. I'm not exactly sure what the intention is and what the behavior should be here, but could you scroll up a little bit, Yakov, please? Yeah, so we can see that too. Yeah, thank you. So if you added, you say con, if an additional type is introduced to house pet that does not implement node, this would break house pet edge. And what we would get is a validation failure, right? So if you added fish to the house pet and it was not something that implemented node, then you would get a validation error right there. Whereas with the unions, with the intersection, excuse me, if you add fish to the house pet union, nothing breaks there, but the house pet node intersection does not include fish. That may not actually be your intention. And you may have missed that, oh, I need to not just add fish to the house pet union, I need to also ensure that fish implements node. And you'll fail silently there until somebody later down the line tries to query this and realizes that their query is failing to validate because fish isn't in the house pet node intersection. Or I'm not sure what the validation rules are even going to be like here. Perhaps they go house pet node ... on fish, and they just never get an object back because fish is not in the house pet node intersection, but that's failing silently. So I want to make sure that we are we're understanding what the way people are going to use this is and what the intention of it is, because if you're going to have that additional overhead of the GraphQL, schema parser and Lexer having to figure out what things are in each intersection. But if that's silent, are we missing? Are we allowing people to miss stuff?
I think that's a great. Point. What I would say is to clarify one thing. One of the possibilities, basically, if you would include on fish, because fish isn't part of the intersection, you would get at the query time, you would get a validation error because it's not one of the possible types. So that at that point, you would get a validation error. And because you're using an intersection, you have to use fragments. I mean, we could, if the intersection included an interface, we could add additional logic to let you query on house pet node directly, but I don't think that's a good idea. I think and I did all the way at the top of this discussion, there's a list of open issues, but I thought for this, at this point, it might make, and that I guess could go into an a longer, into that RFC at some point. And that's one of the open issues, I suppose. But I don't think that's a good idea, and that's not the way it's currently implemented in the PR. So because you have to include fragments, you might get that at query time. You might not if you only query on, if you happen not to need any of the subtypes from fish and you query on the interface, because like the interface pet. So you might encounter that error and failing silently at that point. That is a potential foot gun.
So if you have a field of the type house pet node and you query that field and you're querying selections inside of that field, you cannot then query fields on node. Like I can't go house pet node dot and then in curly braces put ID. I have to go to house pet node dot 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 on node ID.
Well,
I exactly had this because the intention was that you can leave the fragments away, for certain properties.
That's what I thought.
That's also how I understood it. And
I thought it was with unions, with interfaces.
We did discuss that last week, as I think there was actually some disagreement. I think Ivan was against, and I think most people were for, with unions implementing interfaces. If they indeed implement the interfaces, we were okay with. At that time, we were talking about a union called cat or dog node. I think we were okay with querying directly. I think intersections are because they don't have to include any interfaces at all. It's easier to think, in my mind, it's easier to just keep them straight as not querying fields on them directly.
What is the intent then from intersection if you cannot just query something with it? Because then it looks like a union.
It is very much like a union, but it's a union that's been constrained, but not by use of a keyword or an annotation, but by the introduction of a new type with that constraint.
So it's a union, but then it's essentially coming down to this. It's now a union where you can chain in other unions.
Yeah, you could also have an intersection of two unions without any interfaces. That is only the subset. I mean, that's also actually implemented already. You get that, quote unquote, for free, which is either good or bad.
I would find that very confusing. I thought the intent of the whole thing is that you query that you essentially can constrain or that's where I said that you can constrain your union so that that the language server knows that certain fields are always there.
Yep.
Well, I mean, yeah.
Can I also, first of all, I completely agree 100% with Anthony's concerns about this, that essentially it's confusing, and it's regarding validation at startup time, let's say validation of the schema itself. I don't think that replacing it with validation at runtime when actually query fails, it's a good enough replacement. And in general, we had a long discussion of this intersection thing on the side, and I still cannot make sense of it, just because, as you say, you can add fish, but it doesn't implement this node interface, and then it's okay, the validator will swallow it. But then I'm looking at it, a human, I'm looking at it, and it doesn't make sense. It says it includes fish, but actually fish is out. And to understand this for me, I have to actually look at the fish. Oh, it doesn't implement node, so it's out. So declaration says, yeah, it can be fish, but it cannot. How confusing.
I mean,
right?
I think that's fair. I mean, it definitely adds additional complexity versus the intersection implementing interface. To me, it doesn't seem to matter much whether you're allowed to query for fields directly on the union when it's implementing the interface versus whether you have to, use a fragment specifically for that interface. I mean, it's a few extra characters, but it doesn't seem to me to make a large difference.
I'm having trouble understanding what the purpose of this is in general other than that. Like that was what my motivation for being excited about this effort in the first place was, being able to query fields on the union. So can you explain what the other value that this provides is then?
Sure. Meaning that when I started with this, what I'm talking about is this example over here. We're trying to make a type that satisfies an interface, and we weren't able to do that previously. To me, I don't get too excited about losing, a wrapping fragment. I mean, that's just a few characters of text. Whether we have it or don't have it, it doesn't unlock any additional behavior or features or validation within the type system. The motivating example I have here is just can we allow this house pet edge to truly implement edge? Currently, we can't do that. We can't include the words implements edge over here when it's true that it does, and that offends me as an
edge because, oh, I see.
So that's actually a new feature. Now, is it the most necessary feature? Again, that offended me as someone running through open issues on the working group, not as someone in daily practice here. So I don't want to exaggerate the importance, but certainly to me it's not so important to save a few characters of that wrapping fragment.
That makes sense. So from my perspective, just for context, I am the iOS developer at Apollo. So I'm working on a client library that's consuming schemas, and we're doing a lot of code generation. And one thing that specifically compiled applications that use GraphQL, or compiled clients, have that we don't see from the web clients is that we have to deal with the schema changing out from under us. So we compile an application, we generate code, and then we ship it, and then the schema changes on the back end, and we don't have that knowledge. Whereas like a web client is constantly just getting the new schema changes, right, once they're deployed. And the biggest issue for me with unions is that new types are added to unions that we don't know about, and I can't guarantee anything about those. The value of saying, oh, well, I know that this union implements this interface means that I can generate code for the union that I know is going to be valid, even for new types added to that union. And I'm not against using union or intersection for that, but that's a big concern. Like on the usability side, I think it's great that this unlocks this ability to make housepet edge implement edge, but I think that for client developers, the real value of this is the consumption of it in our queries and in our code generation, because being able to query those fields not on another inline fragment, but right on the object or the field itself is really, really valuable for code generation and for being able to smartly analyze and assess what fields are going to be accessible at different scopes and types.
Well, I mean, I can tell you that if something's supposed to return a house pet node and now returns a fish that doesn't implement node and is therefore not part of that intersection, you'll get a server time error.
Right.
Meaning you'll get a query error, I should say, or I guess I'm reminded of, if you use the fragment on fish, you'll get a validation error. But if the server tries to return a fish, you'll also get a server error. So you will get errors on both. And that should help you because
So one thing here is you won't get a server error when the server does have fish implement house pet node, but the client doesn't know that the server has fish implementing house pet node. Right? Because the server is basically in the future compared to the client. I think is the point. Like the server has a schema that is much newer than the client. So when the client was built, fish might have existed, but didn't implement house pet node. But later on, somebody on the server is like, wait a minute, fish does implement house pet node. So
I see what you're saying.
Yeah, like but that ultimately from my perspective, I also am kind of responsible for Meta's client native code implementations. From that perspective, in my view, the using interfaces instead, like using interface inheritance, I don't see why that isn't, I don't understand why that isn't a clean way to solve this and solve the when you see a house pet node, you know exactly which fields are you're allowed to query on them because they're part of that interface inheritance. And it's explicit, whereas with the intersection, much like unions, and one of the reasons personally I hate unions and discourage their use, is that you don't know how the fields will change underneath you. And when you just look at a union, it tells you nothing about what's actually available besides you can do inline fragment spreads for all the types in it, but the server can always add a new type and then you just get an empty response because you didn't explicitly do an inline spread of that new type.
Well, then the server can always add a new type to an interface as well. I mean, a union is basically an interface, an empty interface. So it's not that different.
The nice thing about using an interface is that, right, the ideal here is that you get fields, you get to query for specific fields because you know every type is going to have those fields. By using an interface, you're very explicit about what those fields are at this point in time. You're saying, yes, there might be a future house pet that will come along, but it's guaranteed to have these fields because it's directly on that interface. Whereas you can get into weird situations where people make backwards, incompatible breaking changes with unions, like they remove some type from a union or they remove a field from an interface. And you've kind of, the one worry I have with the intersection is that we're disaggregating field changes on interfaces and on types that ripple through to like potentially make other code. So I can make an existing intersection invalid, like an existing usage of an intersection invalid by removing a field on an interface where that field is never explicitly anywhere in any code on my client. It's like it's never used directly on the interface. It's only used on the intersection. But by removing the field from the interface, now my client code is invalid because of this, like, it basically creates more hops of types that I have to work through to figure out why my code is no longer compiling.
It makes it even worse because you're combining unions and then you in an intersection maybe, and then you're changing a union and you don't even know that this rippled through the intersection now. So there is like it's much more difficult to see how things are affected, and so just
I would say that in general, what we're talking about is well, first of all, again, I would agree there is a lot of complexity that comes with intersections, and those are definitely the downsides. But I think most of the complexity is contained within the idea of a union, and most of the complexity of unions is unfortunately contained within the domain. I mean, the reason why they're not interfaces in their unions is because they don't share any fields, and so you have to, even if you had an empty interface, it wouldn't be, even if it was the keyword interface, you'd be stuck with the same problem because all the fields on dog and cat, there's nothing that are combined. And if it would return a fish, you wouldn't know about it. So there's not much you can do about that problem. What intersections does is it allows us to say that those unions do implement node without having to introduce a lot of dummy types, dummy interfaces over here. And when I say dummy, I don't mean silly, but I mean like duplicate. Meaning here I'm highlighting over here, we're going to have to implement for every union we have, we're going to have to implement an interface house pet node implements node, meaning this is the only field that it has in common. And to me, all of these, they implement node, but they're all just additional nodes. It makes more sense to think of these as of intersections. Now, having said that, again, this is just a number of characters, and I don't like it, but I think if after this discussion, we come down to say that this is still the best, this is the best solution, you know, I think that's okay.
We're getting close to our time limit for the topic, but I do want to bring it back. First, Yakov, thank you for assembling this doc. This is exactly what we asked for last meeting of, can we back up and understand the problem? Can we look for precedent and understand the space a little bit better so it doesn't feel like we're inventing in a vacuum? You've done exactly that. And this feels super detailed and makes it much more easy to compare and contrast possible solutions. So this has been incredibly valuable. I gotta say, I agree with most of the feedback here. Last meeting when you presented the unions implementing interfaces, I thought that sounds so bizarre. It was hard for me to wrap my head around it. Reframing it as actually what this is a union followed by an intersection really clarifies it. But then hearing the pros and cons actually makes me really like your original proposal, because I agree with the original concern that Anthony brought up about one of the thing that felt most strong about your original proposal is that it's not just a filter. Like I see an intersection type like a filter. You take one type and you filter it by another, but it's truly a constraint in the sense that if you do something in the schema that invalidates that constraint, we can statically make noise about that instead, because we know your intent. And that feels like the most powerful part of that proposal. Another thing, I maybe just as a recharacterization of the other domain of feedback that I'm hearing, I'll call it like implicit versus explicit. And that's an explicit trade-off against expressivity. If you need expressivity, sometimes that means your type system starts to get closer to being Turing complete, and you can create outcomes that the only way to know them is to literally run the type system and figure out what the end result looks like. And intersection types certainly fall into that camp. So far, we've intentionally held a principle to keep our type system as explicit as possible, knowing that that will hold our hands in terms of how expressive we'll be able to be. In the introspection API itself, you need to be able to query the possible types for any abstract type. So with unions, that's pretty obviously straightforward. They're all listed. For interfaces, it's just a reverse lookup. You just look at all the things that implement that interface. But one of the things that makes that easy to compute and also therefore easy to reason about is those possible types always have to be concrete. Like there's no follow-on effect. We have to follow a chain. And this kind of would be the first case where we would break that, where an intersection would be an intersection of abstract types where you then have to kind of follow a chain to figure out the end result. And, you know, I agree with the con that you document here about there's complexities that come with that. And is it worth the value that we get and the expressivity that we get? I got to say, I'm skeptical, but it does make me feel better about your original proposal as a really kind of neat solution to the problem that maintains our ability to use union types.
Yeah, I mean, now we have, we have intersections up with an implementation PR, but we shouldn't forget, we have from last working group, we have unions implementing interfaces PR. I think that I discovered a few more tests that I could add based on this PR, but if that's the way we go forward, or if we go forward in no way with the last option, I guess that's, you know, I'm hearing pretty clear feedback that intersections, despite being fun, aren't, you know, come with that additional complexity. So, you know, if we can decide at this meeting to cross that out and go back to last meeting's idea, we could solve that problem that way. So I guess that's, you know, if there's consensus around that, then maybe we can think about, you know, do we have to wait for another month to advance the prior unions implementing interfaces? How do we want to move forward?
Yeah. Sorry, go ahead.
Go ahead.
I was just going to say that not as an official representative from Apollo, but from everything I've talked about internally, we talked about this idea of unions implementing interfaces almost a year ago, and I had basically unilateral support throughout the entire company that this was a great idea and we should do it and it would unlock a lot of things for us. So I'm very on board. Like I want to be a big proponent that we should implement something here. I don't want us to just give up on this one.
I'm coming around to the idea, you know, I want to hold by the principle of the best change is no change, but acknowledge that this is a bit of a gap in the expressivity of our system and the usefulness of unions. By the way, the last suggestion you have here isn't crazy. It's just, it kind of looks like what would common GraphQL patterns look like had we not introduced union types? And the way that you would do that is you would define nominal interfaces, either with no fields, or if they implemented other field interfaces, then you would just repeat those fields.
Do you want to review for us why we can't have empty interfaces? I mean, off the top of my head, I forget.
Because the only use case for an empty interface is a reverse union, which, at least in my personal opinion, is everything a union is, but more confusing. But if you're in a code base that does not have a concept of a union, so hack code bases, I think actually they probably do now, but PHP had interfaces, but they certainly did not have unions. And Facebook's PHP code base was littered with these fieldless interfaces because they were trying to describe unions or unions of things. The last thing you put there is exactly how you would describe a union that has a constraint, and when you had only that one tool to work with. And it works. Like I saw code bases where it works exactly like that, but it's non-obvious as to what that is. You're like, what do you mean this interface that adds nothing? Like, why? And it's a roundabout way of saying a union with a constraint. So I like the explicitness of saying, no, this is a union with a constraint. That's what it is. That feels better. The downside, by the way, of having fieldless intersections fieldless interfaces as a way to define unions is if you end up in a schema that has many unions, where you have a handful of types that coexist across many unions, when you go look up that type, you tend to see implements and then like a comma separated list of like dozens of things of like every union that they exist in, which makes them really difficult to wrap your head around and figure out which of those interfaces are producing value for this type and which of those interfaces are actually nominal interfaces that describe some union type. It's just a confusing piece. But like, yeah, I think some aspect of it is we also have to kind of sleep in the bed that we've made for ourselves. We've introduced union types. People use them quite a lot. It would be bizarre if we said, yeah, we don't think people should be using union types. You should just go ahead and use interfaces as a workaround. That's pretty strange. I will say I meant what I said about this being a very useful exercise, because my biggest question was, this feels weird, and it was difficult for me to explain to myself, despite seeing the benefits. Because of its weirdness, it made me feel like we were reinventing the wheel. What you've done here is prove that, in fact, we are not reinventing the wheel. We are just reassembling the parts in a form that is not typically seen, that provides new value. That if you were in any other strong type system language, what you would do is you would first define your union, then you would define an intersection, and that guarantees that all the pieces that you would put in the union include that filtering function for your intersection, the node interface in this example. TypeScript, that's what you would do. C#, that's what you would do. But for us, what we really want is a schema build time constraint that we can validate, and we don't get that here. So I think like we stumbled on something, a way to talk about this that was valuable last time, to say really what's happening here is a constraint, and the constraint is that all the types must implement node. And that is similar to what you would describe as an intersection. I do think implements is probably the right keyword, just because it is the right way. Like if you were to frame that out as a full sentence, I would say we have a union called house pet, which has a constraint that all of the members of that union must implement node. And then you could start to cut words out until you get to basically syntax. And so the word implements does still kind of make sense there. But I do think people who encounter if we get this to the final phase and introduce this, I imagine quite a lot of people will have the same kind of moment that I had. And if we can accompany this with some clear documentation about why it's the form that it is and how to think about it, this exercise has been super useful for that.
Okay, great. I think the last remaining step then is moving back to the last PRs for the spec and implementation is, do we want to allow querying fields directly on a union that implements an interface? And I don't really have a bone in that.
That seems like pure value to be juiced out of this. If you explicitly guarantee the constraint that all the members of this union will implement this interface, then that sure seems like it should mean that you should be able to query the fields of those interface. So I think that's the work required for the sort of next phase of this, is understanding the ramifications and making sure that we're getting the appropriate value out of it. And that's going to have a bunch of kind of, edge case impacts on changes to the introspection system and assumptions made around that. And Michael's got a good point in the comments too about how we think about GraphQL errors. And so I think there's just sort of like an ecosystem effect, both across the spec and across how we know people are using GraphQL, that we ought to make sure that we have covered our bases on.
Okay, I think this last intersection PR has exposed some additional place in the code base where I have some tests to add for the last PR. So I'll work on refining that for the next meeting, I guess. Is that the next basically action item we could put in, or?
That sounds great. Thanks again for the well-reasoned path through here. This has been great.
Yeah. Thank you for championing this, Yakov.
Sure, it was fun.
I'm going to switch up our agenda order a little bit, if that's okay with you. Alex, I'll have you go next just because you've just got a 10-minute slot here. And I expect we'll get into the weeds with the last two topics.
Yeah, for sure. I just want to let you all know how things are going. We have a first client that has client-controlled nullability support. The Apollo iOS client, their Alpha 4, is relying on a canary release of GraphQL JS. There's no servers that support it yet, I don't think. So it doesn't do anything, but it does code generation. So that works. I wanted to get an idea of like if y'all had thoughts on what rollout of this should look like, since it is an experimental feature. Like, how do you communicate with people who use GraphQL? How should we get feedback from people who are using it? Have we done something like this in the past?
Yeah, but so the latest hot chocolate version for .NET supports it already. So I can spin up a server if you want.
Nice. Okay. Sweet.
Yeah.
Sorry. Yeah. No. Okay. We got two. Nice. Yeah, that'd be tight.
Alex, we're also working on it across all the things at Apollo. Preliminary stages, but we'll have a lot to share with you very soon.
Cool. Yeah, so with regards to getting feedback from people who are using it, or in the rollout part, have we done anything like this in the past? Is there like a process for this? It's like tried and true.
We have, although I don't know that our past ones have been super successful. I think what we've tried before that's gotten a little bit of value has been, once we have it in the, like it's experimental, you got to intentionally flick it on, is we open some issue, or I guess now we have the discussions board. Maybe that's a better place to do that. Basically just to flag like, hey, this is at final phase. We're collecting final feedback. Please use it, run it in your systems and provide feedback. Honestly, most of the people who are going to provide that kind of feedback are in this room. But sometimes you get lucky and more folks will try it out and report back with stuff that they learned.
Okay, cool.
I
also, sorry.
What about Relay guys? Do they have more feedback on, or do they even have implemented maybe client-side nullability? Or as far as I know, they started on experimenting with it. Or I mean, there could be feedback. That's what I mean.
There is Matt's here, right? Or I guess
I'm
Matt's
here, Jordan's
Relay.
not. Yeah.
Yep.
Yeah, Jordan's probably the best person, but so just be concrete, Relay has not done any work with server capability of client-defined nullability, but they have basically a facade of it that fakes it for the client.
Yeah, that I saw. But I thought that's just like duct tape, but they actually want the server to do it.
Yeah, we probably, the way Relay does it, it likely doesn't make sense to pursue, from my understanding. I could be putting words in Jordan's mouth, so not 100%, but it probably doesn't make sense to implement server-side client-controlled nullability until we have some mechanism for fragment level keys, or like basically being able to say this fragment like is null.
That's my understanding too, is that they're gonna strip out any client-side designators and then sort of do the processing with whatever they get back on the client.
I think they were still interested in using the syntax, especially because I know there were still a couple of open discussions around the exact semantics of those things. And if they can line up with what we've learned from people using Relay, then that has the added benefit that the syntax for people who use Relay can just directly use null propagation punctuation rather than more verbose directives.
Mm-hmm. Yelp is going to be piloting the thing. We're probably a couple quarters out, but gonna be piloting it. Do we know of any other companies that are intended to try it out pretty early on?
What is Yelp server stack?
Yeah, so most of our stuff is in Python. I think we use Pyramid, and then but our GraphQL service is Node.
Okay. So on the server side, we have an implementation of this, but it's not quite compatible with the versions going into the spec. But we could look at how much it would take to get that compatible, and then I think our clients would love to try this. We are using Apollo's iOS client and JS, and so if we could get our server end to match, then we could get some feedback from our UI developers.
Great.
Yeah.
Cool.
On our end, on our end, the big question, and I know it's been glossed over because we can solve it via validation, but is that it introduces another aspect of basically fragments from various products having more overlapping complexity, which means I can mess up somebody else's product by I can make it impossible for some other engineer far in another organization even from being able to iterate on their own stuff by introducing this by introducing some client controlled nullability that's used in a very central query. And that's probably not a concern that should block us from moving forward and advancing, but it will block that is really, I think, the main block for Relay, pushing it and encouraging it on Relay level servers.
Yeah, for sure. I don't expect everybody to use this out of the gate. It's very early on. But I wanted to see if anyone else was, just so we can coordinate and gather feedback and whatnot.
Well, Matt, would that be solved by your fragment modularity proposal?
Yeah, basically the whole point of the fragment modularity proposal is that we want to create more locations where teams can declare themselves basically independent of changes happening elsewhere in the code base.
Right. Gotcha. Yeah, I know I was the most vocal anti-fragment modularity person on that thread before, but I have thought about it a lot, and I do think that there are use cases where it makes sense. So I think that we should probably, I don't know if you guys have been moving internally forward on that one, but we should probably bring that one back to the forefront at some point.
Otherwise, we're looking to merge the parsing and lexing portion of the implementation relatively soon. Ivan got me a review like minutes ago. And then I think the primary blocker for execution is we have to land on how errors work. So I'm going to come to the next working group meeting with some discussion items, so we can talk about that.
That sounds great. Maybe the best way to collect the feedback is to create like a canonical discussion thread that's just asking for feedback on this with a bunch of pointers out to the places to pay attention to, whether it's the alpha release or and then like a list of topics of things that you are still trying to make final decisions on that you explicitly want feedback on. That way there's like one nexus point for people to deliver that feedback to.
Yeah, I wonder, I'm trying to think of like a good way so that like if someone stumbles upon this flag in a blog post, I want them to know about the discussion thread. So I wonder if there's a way that we could say like, oh, you're running execution with this thing open, you know, we're going to log like a link or something to this discussion thread. Come tell us about your experience, or I don't know. I'll think about it.
Yeah, having like a master discussion thread or something might be helpful for that, just because you can just, you know, keep like a category of links.
Yeah, for sure. Okay, cool. I think that's everything I had.
Awesome.
Do you want me to add that as an action item to create that thread discussion?
Sure, yeah.
Good question. You remember at the end of the last meeting in the discussion, I mentioned this suggestion to rename this client-controlled nullability into client assertions, because I thought it was confusing, and it was kind of greeted well, this suggestion, because I think this is confusing to call it this way, client-controlled nullability. And it even seems like if something it actually throws error or something, it's violated, then it's kind of server error, while in fact it's failed assertion. And you remember this at the end, so that I think it would be less confusing and more clear. What's actually happens here is that along with a query on certain fields, the client sends, please make assertion, check that this is not null. Client controls nothing.
What is the inverse of assertion for the optional one when you make something optional with a question mark? Because for the exclamation point, that's an assertion for sure.
Then this is impossible. When question mark, it means that essentially, as far as I understand, its only use is on the upper fields in the tree to allow this thing to be null. You cannot actually make nullable what is not nullable on server, right?
Yeah.
So it's an addition in concert with this, with the exclamation mark, right?
I agree with the feedback. To generalize, maybe it's just we ought to take a step back and make sure that we have the appropriate names and ways to describe these features, which Alex, to your point, you're still trying to figure out the exact semantics of these, which may have like the name that makes sense for one semantic would maybe be confusing for another. So I think there's a little bit of a tight tie between those two. But certainly I agree. We ought to make sure the name we land on makes sense. Like I've been thinking about the question mark as an error boundary rather than as something like it just happens to change null effects, but that's more of a result of how their error handling behavior works. But the actual usefulness there is that it's an error catching boundary. I like the idea of thinking about an exclamation point as an assertion. Other languages have similar sort of behavior and even similar syntax, and I think they all use different names. Swift uses unwrap, which we don't use the idea of types being wrapped necessarily, or we do, but not in the same way. So yeah, maybe making sure we get that right. Good feedback.
Yeah, let's just continue discussion at least.
Sure.
Right.
Yeah, we can put up a discussion thread. Yeah, we'll do it.
Yeah, I actually wanted to ask for the same thing because I'm reviewing PR for GraphQL.js and we enable it with Flag. And I can like help with all implementation details, and Alex did a great job. So I'm like doing finishing passes. What's worrying me is like naming. Also IST nodes, how to name IST nodes, even though we match only like parsing and not semantics, execution semantics. It's like experimental feature on the Flag, but if later we decide to remove it, it's breaking change for GraphQL.js. And it's also breaking changes for all the implementations that will do experimental flags. So I'm totally for discussion naming upfront before we commit to API, since it like save us bunch of dancing with breaking changes or like supporting two names of the same field and doing some other weird things. So I wanted to ask people to review PR, but actually like for naming separate thread makes sense.
Yeah.
I think what we really need is like generic name for like entire syntax, question mark, bank, and square brackets, because in IST we have one union type of 3 types of nodes. So it should be generic name for like square braces, and name for bank, and name for question mark. So like 4 names basically, like of things. So would be great if we set up a thread to discuss with 4 and decide it before we merge. Yeah, and like
I do want to say, I don't want perfect to be the enemy of good, especially while we're in the phase of prototyping, experiments, and iterating. Like, because we could spend an entire month trying to get the name right, only to like tweak the semantic based on feedback, and all of a sudden the name's wrong, and that would have been wasted effort. So if we can pick a name that feels reasonable given the direction we're headed, and just instead make sure that we're set up such that a change in name won't cause a dramatically painful effect later.
I mean, there are names out. I mean, especially for the syntax tree, I'm also have concerns with the names, but there are names out there for similar tokens in C#, Java, or whatever. So we might just need to have a look at their syntax trees.
It's worth the discussion. Maybe the action there is a separate discussion thread, just to kind of go through some naming options, and great suggestion, Michael, to look at some precedent.
Yeah, no, I think it makes perfect sense to discuss this now rather than later, before you go and publicize a bunch of stuff and then people are confused and they're like, what, there's 2, 3 different things outside? Yeah, no, much better.
That's really the blocker.
Okay.
Yeah, we don't want to like be writing big blog posts and I mean, we can always talk about work in progress, it's fine, but like once things are codified, of course we want the right names, but we'll get there.
Yep. All right.
Let me bring some philosophical thing. There is a saying, if you want to understand the thing, name it. So proper naming brings a lot, I mean, of understanding. So it's kind of important, at least for end users. For internal naming of variables, yes, but we have to think about end users. So proper name should bring them immediate kind of 50% of understanding. What is this?
Totally agree. All right, Alex, thank you for the update.
Mhm.
Exciting to see the progress. We will hand it over to Defer and Stream next. Yakov, do you have the first piece of this?
I do have the first piece. I think it might, I don't know if Rob wants to go forward with his first, that would be fine with me. It's sort of both are a continuation from last week.
Since we didn't really discuss yours, maybe you should go this time.
Okay. So basically, I discussed or I reported on, I guess, some possible issues with the performance-wise, I guess, of Stream, where we might want to yield a subset of items in one payload rather than yielding each item by item. And that occurs at two levels, basically. That's when a resolver is returning a list of items, and as well as when the overall async generator returned by GraphQL.js is returning payloads with possible multiple completed results. At both of those levels, we have to decide whether we want to be able to return lists, subsets of items. So I could share my screen again of what the discussion was, but I'm not sure how much people remember from last time or how much we want to go through those. If anyone has some immediate feedback, because we didn't, basically I spoke last week and we didn't get, we sort of ran out of time right before people possibly would weigh in. But I'm going to share my screen from that discussion, and I can take it from there in terms of how much more people want me to speak. I'd much rather hear what other people have to say. But if no one else is going to speak, then I would definitely remind everyone of where we were.
Yeah, maybe a quick reminder would be helpful. This is specifically in the domain of what like types to use in terms of async generators, arrays, or is it more the like delivery payloads?
It's basically here. Let's take a look at the suggested type signature of execute over here. So what we have right over here in our execute function is we're right now returning a promise or value of an execution result or of a async generator. And that's the same as what's currently in the implementation. But what goes inside this async generator? So what I would be suggesting is that we would return an array of execution results rather than a single execution result. But that same question is on two levels. What should the async generator or async iterator that we return, meaning the GraphQL algorithm and function returns, as well as what the resolver, we now, with incremental delivery, we're going to now allow resolvers to return async iterables and not just iterables. For the same reason that we might want to return batches of results if they're all available at the same time, we might want to let those underlying services that are returning async iterables that we then of items that we then complete, we might want to allow them to return batches at the same time. So there would be a similar, there's really two separate issues, but for me, the exact same motivating principle. There is the signature of those async iterables, and we're a little more generic there. We allow those to be async iterables, where we return an async generator, which is an async iterable iterator, whatever. But the question is, what should be inside this? Should it be an item or an array of items, basically? And I want us to think broadly, because if we can get agreement that all of the items should be returned available, it doesn't have to be an array. And similarly, the resolver doesn't have to return an array of items. It could be an object that contains an array. It's just, if we can all agree that it has to return all the that we should allow returning all the available items at the same time, we can then sort of, drill down to how we would do that. Would it be a simple array or would it be a more nested object? But I guess the first question is, do we want to not allow that? Or do we want to allow it? And the question is right now, I'll stop there if anyone has initial.
It does seem to me that it will be incredibly useful to ensure that as batches of data is available, that we can deliver batches of data to a client, especially since this isn't just a matter of a fiddly how it's described in the payload kind of thing. Like this would have a meaningful difference in terms of how a client would consume that, right? Like if your client is going to consume the results of asynchronous execution and create introduce that payload into the store, recompute UI based on changes to that store, knowing that you have 3 changes that logically happened at the same moment means that you're doing one operation to update your store and one operation to update your UI rather than 3 in immediate succession, which could create significant performance issues, as well as like visible UI shearing or other like weird behavior. So it seems very useful for us to be able to represent batches of results that happen simultaneously. The one just like minor piece of feedback is I wonder if the suggested type signatures for execute and subscribe could be the same. Like I know subscribed, you've tried to make sure that you don't break the existing definition by making sure that we can do an async generator of a result, or it could be an array of results in the case that there's multiple subscribe payloads simultaneously. Should the same be true for execute? Like should the sense that this is like, I imagine that the vast majority of the time, these will be arrays of size 1, and async execution result can never be an array type. So would a potential, I don't know if it's a simplification or not, or just the unifying between the two be it's either an execution result or it's an array of execution results?
I mean, I thought of simplifying basically the other way, is that we always have an array, even if it's an array of size 1 for both execute and subscribe. But I do agree it would be nice if they had the same signature. I don't think it matters to me so much, although which one it picks. Do we have broad agreement from, I mean, any other, is there any like a dissent, I guess, or would say like in terms of?
Yeah, one thing is like particular to not about general idea, but developer experience from a person who uses that. So it's surprising that I think generator can return like a value, and you return like sequence of a value, but you need to wrap. If you don't care for simple cases and like what people implement as a first version, for them it would be more logical to just implement a sync generator. But now we force them to wrap it in array. What's even more every item. So what's even more surprising if you need to return array as in your resolver, if you want to return array, so we need to like have some like doubts about the developer experience of person who implement resolver on who implement resolver basically.
Yeah, I was thinking it would kind of be nice that it's forcing the client developers to consider returning an array if everything is always wrapped in an array, because then they're not getting into the chance of the foot gun of thrashing their client re-rendering on a lot of payloads.
I'm just scrolling to where the implementation that I have up for for this within, so I'm trying to find it within GraphQL Executor. So that's what all the screen changes are.
Can I ask a question? I'm just wondering, why is this discussion here? I'm looking at the document and it says a spec change does not seem necessary. So this looks like particular JS or GraphQL JS coding implementation issue, which does not involve the spec in kind of any way.
Yeah, I mean, I did point out that for the resolver signature, I'm not sure that a spec change would be required. The spec alludes part of it to how we would handle async generators, returning a resolve, a field generators, if I remember that's how they're referred to. But it sort of implies actually that you're not returning arrays, you're returning single items. And so I think we would want to clarify that. But other than that, it's sort of an illusion. It's not specifically in there. But in terms of the response of the actual GraphQL payloads, that certainly is in the spec. And I guess that has to be clarified. But you're right, the other part isn't. So I do link to two separate spec changes that PRs that I would make.
That's part of why I was also asking, like, is this more about the specific JS type system changes that you want feedback on, which totally okay to ask for opinion here, but I also broadly agree. Or is this more about the shape of the payloads that will come from this? Because I know we had a brief conversation before about whether we wanted to allow arrays of results, and is that at the top layer? Like, there's direct impact on, if we make changes to the shape of that payload, that implies something about the underlying types that are necessary to represent those, and vice versa. If you make some change to the types here, that will imply what you can and can't do in terms of the payload shape.
Yeah, I think they're definitely related to payload shapes. And I guess, yeah, you could construct it in a way maybe that isn't, but I think practically they are. Anyway,
at least for the execution result. For I mean, maybe we should talk a little bit about the return from the resolver, because I feel like that one is more of an implementation detail.
I mean, I'm highlighting basically the one change over here to the to what you would return. I mean, you're yielding an array instead of a resolver is allowed in its signature, I believe, to return anything. And so the signature of the resolver type doesn't change in the implementation, but then we do add some validation that in the execution, that if you don't return an iterable, then you're in trouble with the big execution police. So yeah, so that's over here. That's over there, and is so. I mean, I guess we're broadly in agreement that this is a good idea, and we should just make sure that when we talk about the payload format, we keep that in mind. Is that where we're at?
That's my read. Yeah, making sure the payload shape captures both the flexibility to represent simultaneous events in a batch is important. I see the immediate ramifications on that, on UI quality and performance. While also the point I was making before about whether there should be a value or like a result or an array of results versus just an array of results, is we should also make sure that the common case is easy to understand. So if the common case is, if 95% of payloads are going to be, or 99% of payloads are going to be array of size 1, then you can imagine 99% of GraphQL users will be questioning why the heck that array is there. And just the 1% who has the use case of the batch is going to be happy that it exists. So there's just some fiddling there to make sure that we get both of them right. But I think broadly making sure that we have this capability seems quite worthwhile.
Okay, I think that's great. And then I guess we can take it back to the implementation working group or just out, out of band discussions.
Great. Rob, you want to take it from here?
Yeah, sure. So the past couple of meetings, we've been talking about the payload for stream results. We went through a couple iterations. In the last meeting, we decided on that we should always be returning an array in the data. For now in size 1, because we won't be supporting direct batching. The original payload that we had the index of the element in the path array. And there was some discussion of, is it necessary at all? Because we're always returning payloads in order. Should it be in a different property on the payload? Or keeping it inside the original, keeping it inside the path, new property, or omitting it entirely. There was a little bit of discussion, and there is a use case that there's this scenario that came up where it is ambiguous without having the index in the payload at all. And that is the case where you have 2 deferred fragments somewhere with the same stream nested inside of that fragment. Each defer is going to start a separate execution, sort of, and you're going to get the stream payloads that originate from both defer. They have the same path, they have the same label, and so there isn't a way to distinguish the order, because they could come interspersed with each other. So I think that because of that, it's safe to rule out the option C of omitting the index entirely. So I guess I want to hear thoughts on the other 2 options. Where I'm leaning towards right now is a new property that we could call @indices and have that be an array also of 1 now, and that gives us room for expansion for supporting batches. We could have more than 1 indexes in there that corresponds to each item in the data array, or we could also support sparse responses where they're not coming back in order or they're skipped. And I feel like that is what gives us the most flexibility.
I do worry about the trade-off between flexibility and the complicated logic necessary to merge these results back together. I think where we'd settled up to now of to say first, yes, it is useful to represent multiple elements of a list coming down simultaneously, because we know that that's a pretty common feature of backends to stream in chunks. And so we can also stream in chunks per list, which I think is a different thing from streaming like multiple things happening within the tree. But these are all just kind of clean concatenations. It's given this path into the array, then the data here gets concatenated onto that array. Are you saying that there's an ambiguity about how to perform that concatenation?
Yeah, there could be, in the case where you have the same stream on, if you have the same deferred fragment, the same stream inside different deferred fragments. Their deferred isn't doing deduping of fields, which is something that we had talked about a long time ago and decided against. It kind of gives exponential complexity when you try to get into it. So you would be getting the stream payloads for this field for each defer. And because it's the same path and
But
they could be, yeah. If that,
I wonder, I mean, that's a very constructed case. I mean, usually to make it useful, you would have arguments. Then there would need to be a distinction, right? And then there couldn't be
for sure, yeah.
like this repeatable stream.
Yeah,
like
this is definitely not
like,
a common case then.
Like from a server perspective, I could even, I mean, you specify to get it with a special label, the defer, but essentially they would be mergeable if they hadn't defer on it.
Right.
So it's essentially the same. I mean, is it even necessary to make it complex, like to add this complexity just for a case that we don't really have, or that we might remove? Like we could even say you cannot do that. That makes no sense, or I don't know. Because to make this useful, you would need to have arguments and say, okay, I want this section and this deferred fragment and stream that data, and in this section and something else.
Yeah, I'm open to it. I still do hesitate that just not having that index in there anyway is somehow going to bite us later.
Yeah, I kind of agree with you there. Like, even if it's obvious use now, is just to validate that the world is in a state that you expect it to be in when you start to perform that concat or merge or whatever. Seems good because it's entirely possible that we've missed some corner case and then that catches the corner case. But this example is very interesting. This implies that there's essentially two simultaneous streams of the same list that appears at the same spot in the final merged result, right?
Yeah.
Yeah, because we don't have the parent label, essentially. In this case, it's because we don't get the parent label. It's only caused because we are in the deferred section, right? And that's why we take it apart. If we didn't have these two defers on there, we would merge it. Like the server would use the field merging rule, and then this problem wouldn't appear. But now that the result essentially is spliced, or we are spliced in the processing there. And I think it's very constructed because it's the same. It should resolve in the same. I mean, the list, if it produced like random numbers, okay, because we are running them essentially in different threads, they could produce different results. But it's a very constructed case.
And this isn't a case where, barring the label argument that's here, this isn't a case where you could just take a look at these two fragments and say, these fragments clearly are duplicitous. Like, if this wasn't deferred, we would not have fetched the same field twice. We would have done field collection and fetched that field once. It just happened to be visited via two paths in the fragment, right?
Yeah. Yeah, I mean, you can construct more complex cases here, right? That's very simplified. So this we could easily analyze, but as it gets more complex, you might run into the same, where you couldn't just say, okay, we drop, we merge them.
So
do we actually need to support nested defer and stream? Would it be sufficient to only allow one level of this and then just get rid of the problem entirely? I am worried about if we do fragment composition and you have like deferral stream and a fragment, you then can't compose it inside of another deferred fragment or something like that. But
I think
nonetheless,
that's too costly for composition. It's inevitable that you'll want multiple layers. Like, it may be the case that most uses only have one layer deep, but this defer with the streamed list inside the deferred piece seems actually like something that's going to fairly typically happen. So
we have a full application, a demo application written for these cases with Relay, and it's very easy to compose them. Like even because you are essentially putting components together, you don't know that a few layers up, somebody.
If I can reframe the problem here, it's actually really what we want to be able to do is describe any asynchronous payload that's going to be merged as an idempotent action, right? Because if the same list is being streamed twice, but all of the merge operations are idempotent, then you're just burning CPU, but at least the end result is going to be the same because the second merge that's idempotent will just do nothing. And maybe that's the thing that we've missed here is we've made the assumption that there will be an existing set of lists and then you'll get data and you must concat it, but concat is not idempotent. If you ask to concat the same thing twice, you'll end up with two of those things in there, not one. If it's like set at index, that's idempotent, but it limits us to only being able to do one thing, then perhaps the being able to buy back having a range is actually like set at index range. It's from this index to that index. These are the values, which I think is similar to the at indices, but at indices implies that rather than that being 2, 3, 4, it could be 7, 1, 3. And I think that's where things start getting a little bit more harebrained. And if we can hold the constraint that these are always some contiguous range within the list, that makes the merge operation a lot easier.
So as some flavor on like what we actually do. So I just tested this internally and we do like at Meta, our implementation of AdStream does in fact merge the, like we cannot give you two instances of the same item in the list, like in a streamed payload, even if it's underneath the, I just copied the exact same structure. So maybe the answer is that we really do want to ensure in a response payload, even if you're getting some stream under some defer, is it required that you know which one it came from? Because it is the same, like maybe like the path dedupes it. Is it okay to just force the server to in fact guarantee that it gets that, like it will only send to the client one instance of each item in a streamed list?
I mean, it sounds like no, right? Like maybe what you built so far in meta servers handles that, but it sounds like that might violate the principle of allowing servers enough flexibility to do things performantly. And either way, seeing this is shaking my confidence that we'll be able to make the guarantee that we'll never provide you a set of updates that will put you in a incorrect state. So and if the takeaway from that is every one of these, you know, here's the new data at this path, like if each of those operations are always guaranteed to be idempotent, then hopefully in addition to that, we can also say servers should not give you, you know, a set of payloads that don't really make sense or contain a bunch of duplicitous information. That's clearly also not good. But at least the worst thing that could happen is that you just like spin a bunch of compute that you didn't have to spin rather than putting you in a bad state.
Mm-hmm.
Yeah, I would definitely like to know what logic the meta server is doing to dedupe those, because it's definitely not something that the GraphQL JS implementation I have is doing.
Yeah, interesting would be because like how is it working with data masking in Relay? Because you essentially need to know for which fragment that would be on coming the data on.
You kind of do, but for Relay, the Fragment ends up, so like the fragment knows what is, you have fragment level subscriptions to a central store. So the way defer and stream kind of work for Relay is we know an update happened to this node in our normalized store. And that's what causes the re-render rather than like a specific payload came from the server that happened to be the defer payload, at least as I understand it. I could be wrong. And I can ask Kawai where the logic is for this.
It might be interesting, or it's entirely possible you have this latent bug and you've just never hit it.
Possible, very possible.
Here's a thought, especially if, because you can correct me if I'm misremembering, but my memory is that we kind of settled that option A, that's where you started, and that's the most reasonable since it maintains this idea there's kind of like one way to define paths, especially since if you had to walk through a list to get there, you'd have the index in there anyway. Maybe this is just kind of a subtle redefinition of the expected merge operation by a client. Instead of saying, hey, given the path and the data, you can kind of ignore that index. And what you should do is you should concat the array of items in the data to that list. What we're now learning is like, no, it may be that 99% of the time that would be an equivalent operation, but that is not the operation. What you do is you say you are you're setting at a range where the beginning of that range is found at the index in the path, and the length of that range is the length of the data. So if you have a list of length 2 and then person films 2 is the thing, then that sure looks like a concat. But if you have a list of length 3, then this is actually a set at index 2. And if you had, multiple items in that data and this index comes in the middle of that, then it would be setting at that range given that length. That would be idempotent. That would hold to the exact same set of data that you originally proposed.
So
Yeah,
essentially,
that's kind of what I meant.
Yeah, and that just means if there is coming the same data again, we just override it.
Yep, exactly.
Yeah.
You're Rob, you're a step ahead of me. You've already written that down in future expansion. Yeah, so I think that's just the way that we describe how the operation works, and then that's equivalent to what we've been doing up until now. It's just kind of future safe, or at least resilient against the potential to have that edge case. It buys us that idempotence.
Yeah, the only thing that it might make trickier in the future is if we do want to support the out of order payloads for sparse lists. But I'm not sure. Yeah,
we preserve that because if there's a difference between saying here's a single operation where I'm setting at this range from here is a batch of asynchronous payloads, going back to Yakov's point of making sure that we have the ability to represent arrays of asynchronous results. You can imagine having 3 events that happen, quote, simultaneously, that then say set at index 3, set at index 1, set at index 7, and that gives you the ability to do out of order payloads as sort of multiple events that happened in that stream.
Right. Yeah.
Which would be then that's still preserved, but that would allow us to keep this particular piece to say we expect lists to come back as continuous blocks of data. So anytime you see the data here, that's representing a continuous block of a list, which could be one, it could be the whole list, it could be a subset of the list, but it's always going to be a contiguous block.
Yeah,
I
makes
have a
sense.
question. I have also a question regarding the attribute has next. Aren't we mixing the concepts of the sequential and random access to the data? Wouldn't it be more reliable to provide just the size of the array instead of just giving providing the Boolean flag saying that there is a next chunk of data?
Yeah, so the has next refers not to the individual stream, but to every payload being returned by all the defers and streams in the operation. And that it could not, even with a single stream, that could not be known ahead of time, because you could have a your underlying data source could be some kind of async generator or something that you don't know synchronously how many items are in the list until you've read them completely.
But
So
do you have a guarantee that there will be always such an order of the chunks that the only very last chunk will have this flag set to false?
Yeah,
if it is all random, if it is all asynchronous.
Yeah, and in the case where we don't know at the time of the last one is sent, we have in the spec that you could send a payload that just doesn't have data, label, or path and just has next true.
Yeah, that was one of the very early problems we ran into. So that's solved by most implementation.
That does, I'll wrap this up because I want to have a little bit of time for Benji. But it does open maybe an interesting question, and maybe we just decide we don't want to tackle this. Is do we want the ability to signal that the stream of a particular list has completed while the rest of the query may have other defers or other lists that are being streamed, such that you say this particular chunk of data for this path is the last one?
Yeah, that is something that I have an issue open for. We were kind of leaning towards not solving it now, but something that could be added on later in a new property or something like that. But if we think that's something that needs to be in the initial,
I don't have an opinion on it. It's just occurred to me with Greg's comment.
Yeah, we do have a topic for that.
Okay.
I guess just before we move on, I just want to summarize. Are we generally leaning towards sticking with option A, but updating the language that it's to basically say what I have highlighted here?
That would be my suggestion, unless anybody disagrees.
Okay, great. Yeah, that's already what's implemented. So I will just make sure that the spec wording is accurate.
Awesome. Thanks for building confidence around this.
Yeah, thanks a lot for everyone's feedback.
All right, Benji, sorry to give you less time than you asked for, but hopefully we can get through some of what you want to talk about and cover the rest next time.
That's all right. I wasn't expecting to talk for particularly long, but I thought that the discussion might go long. I apologize. My cat's just jumped up next to me and she's going to be very noisy. So I apologize if there's a lot of meowing. So the one-off proposal, I've been dragging my heels on this for a little while. And the main reason is it's not immediately obvious whether this should be part of the output schema or not. There are arguments for both directions. But anyway, as an update, as I gave earlier, the spec PR is finished for adding this as input, and the GraphQL JS PR is also present for adding this as input. So we could theoretically merge it. But what I want to know is, have we satisfied ourselves either? Well, basically, we've agreed that we should add this as an input first and then maybe as an output later. But what I don't want to do is come to add it as an output later, realize that we made a mistake and that would have affected input. I'd like to answer some of the complex questions around output before we merge it for input, basically, even if we don't know all of the answers. So it basically comes down to this. Do we want one of in output types? If we do, we get some cool new capabilities. So for example, if we were to use it as effectively a replacement for union, then now unions can also represent scalars, they can represent enums, they can represent lists, which is new capabilities, which is really nice. But what does that mean then for unions? Are unions now semi-deprecated? And it also is interesting when we combine it with Yakov's proposal to make unions more powerful as well. Do we want those two sort of competing forms of polymorphism there? If we don't want to add it as an output type, then is one of on input types definitely the right solution? And my main concern there is having two types of polymorphism on output and then a type of polymorphism on input that's completely different shape and supports completely different things, like supporting these scalars, enums, lists, as well as input object types. That does seem strange. So I've been struggling with this question in my own head for a while, and I haven't got any answers. So yeah, does anyone have any thoughts, please?
I gotta say, it's pretty entertaining watching essentially closed captions of the notes appear directly behind you as you speak. I love this. I have some thoughts here. I think you're on the right track. My suggestion is, considering how much time and energy we put into this so far, we ought to be decoupling away the parts that are less clear to make the parts that are clear closer to doable. The original problem to solve here was input unions, and I think we ought to stay focused on that goal. But I definitely agree with your concerns. I do think, to answer your question on would one of output types still be useful despite creating multiple ways to represent unions, my sense is definitely yes. It certainly buys us the describing the differences between the two and when you would use one versus the other, but it doesn't seem like one clearly slam dunk replaces the other. It gives us more flexibility and a better tool for schema definition that I think is good. Perhaps the right way to do this would be exploring output one of types far enough so that you build confidence that there would not be some game-changing way to do output types that change the way that you want to do input types. If we're in the weeds of talking about the details of the impact on the output type system, and we feel very confident that none of answering those questions would change how we're doing input type union or input union types, then we ought to proceed forward with the input unions. And I don't know if that list is known or if that list is all checked off. But that would be my suggestion.
Yeah, that makes sense, and I'm happy to do that. I do think that if we are potentially in the future going to add it as an output type, doing that research now makes sense. There was, however, there was a number of strong voices saying we should never add this to output types, and I'm saying if people feel that, then now would be a good time to say it, because that may affect whether or not, the input types is the right thing. And it might be that we have to research the whole thing, make a decision later, and then go ahead and merge them for input. But yeah, if anyone has any strong contradictory opinions, now would be a good time to voice them.
I mean, I definitely agree with what was said, Benji, about the concern that this kind of overlaps with unions, and one or the other is going to be, you're going to have two competing things that people are using to do the same thing. What is the right best practice when you use one or the other? Different teams are going to have different ideas on that. And then things like when we want to make unions more powerful, do we do that to both these one of output types as well? Like, do we do different things for each of them? Why would you pick one or the other? You get trade-offs. That becomes really, really dangerous. I don't have a whole lot of context on the history of this issue, but I know that we've talked about doing some sort of unions for input types. Just really quick summary, can somebody tell me why this was chosen as a better alternative to like extending unions in a way that made them solve this problem? Or is that way too much of a conversation to have right now?
For our remaining 2 minutes, I think it is, okay. But there is documentation on this that's certainly worth the read.
I'll look it up.
Benji, I'll say we ought to separate design from decision. So it's one thing to say, hey, if we were going to do one of output types, we feel fairly confident that this is the appropriate way to design them. But that does not mean that we say, yes, we are, or no, we're not going to do it. Because it could be that, like, okay, the thing that actually makes us conclude that it's not worth doing is it's just not different enough from typical unions, and it's going to add more confusion than benefit. But that like answering that question wouldn't change the design. Answering that question would just help us decide whether or not it was the right thing for the overall GraphQL surface area, and therefore would also not change input unions. And I think the reason why we got on the tear of output types in the first place was at first realizing that polymorphism between these would be a valuable thing, perhaps even type reuse. I think we proved to ourselves via a lot of hard work that that was probably not the right thing to do, that there was too much pain. But via all that conversation still landed that one of was clearly the cleanest way to do input unions. And so I still feel bullish on one of output types as providing value, but I mean that to the degree that we ought to continue exploring the design space, especially if that helps us validate the input type design space. So hopefully there's not like, I don't want it to end up in this position where we have to have the full discussion about whether output one of types are worth doing or not in order to make any progress on input union types, which is sort of the entire reason why we went down this path in the first place.
Yeah, I agree. So if we're still agreed that even if we don't have output one of, it's still good to have the input one of, even though it doesn't match the output polymorphism, then that's great. In which case, I suggest that we move it to RFC2, since it already has a GraphQL JS implementation, it has a spec implementation. I think it is ready to go. I don't mind if we do this next week, if next month, if you want to review it and such though.
Sure. I'll do that now. I mean, worst case, we decide that that was wrong and we move it back. But knowing what I know, I think that's probably a safe change. And then from here out, we ought to then validate that that draft is in the form that we want it to be by exploring the output space as a way to help build that confirmation and the rest. But yep, I think it's been sitting in a fairly solid state and warrants RFC2. Done and done.
Fantastic.
All right, with that, we're wrapping up almost exactly on time. So thank you all for the healthy discussion. We covered a ton of ground. We're working on a lot of really interesting things. So much appreciate all the hard work that you've all done and the great discussion here. Bring the same energy next month. And thank you all so much. Talk to you again soon.
Thanks, everyone.
Take care.
Hey, guys.